Hello students, welcome to my YouTube channel Physics with Msir. If you are new to this channel, please subscribe the channel, and if you like the content of the channel, please do not forget to press the like button, because this will give me more motivation and I will try to bring more information and more new topic for you. So let's start the topic. Okay. So here I'm going to discuss with you what is refraction of light and how refraction takes place, etc. Correct? Please listen very carefully. So first of all, what do you mean by refraction? Before going to start refraction, let me tell you one important thing. Few important points you need to know. Correct? So number one point is the speed of light is maximum in vacuum and vacuum or air. In general, it is slightly lesser in air, but we consider it more or less same. And that is approximately 3.0 into 10 to the power of 8 meter per second. Number two, the speed of light is different in different media. Light is different in different media. Different media. Okay. Now, refraction of light actually mostly related with the speed of light. Correct. Now, actually, what happens? So, let me describe first what is refraction. Refraction. When light moves from one medium to another, its speed changes. And because of this speed change, when light falls obliquely on the separation of two media, it deviates from its initial path. Clear? And this phenomenon is called refraction. So let me write it down. The speed of light is different in different media. Sorry. The speed of light, sorry. Just a moment. When light moves from one medium to another, its speed changes. And because of that, this is very important. Huh? Because of that, when light falls obliquely on the separation of two media, it deviates from its straight line path, not straight line path, its initial path. It deviates from its initial path. And the phenomenon is called refraction. Okay. Now, it may come to your mind because these people are very new to this concept. Okay, what do you mean by deviates? Okay, let me explain this first. What do you mean by deviates? So, let me give an explanation of it. Correct? So, let's watch it. Let me draw a diagram. Suppose this is the surface of separation of two media, and a light comes like this. For example, it falls like this, okay, and then let me draw a normal so you can understand this better, correct? And suppose the light goes like this, correct? So what I mean to say by deviation, look, if I draw another diagram on it, it's another line on it, look, this is the actual path along which light was going initially, correct? This is the actual path along which light was going initially, clear? But what happens after falling on this surface? It follows this path. So if you check this angle, it is theta1 and it is theta2. So these two angles are not same. It means what? The light is not following its initial path. That means that shows by the red line, correct? Now, clear? If it follows the red line, it must go along this black path, black line path. But instead of that, it is moving along this. So what does that mean? That light deviates from its straight line path. Clear? Straight line path, na? Initial path. And that is what we mean by deviation. Is that clear? Now, how to calculate the angle of deviation? How to calculate the angle of deviation? Correct? So let me show you to you. So how to calculate the angle of deviation? Okay. Now, if you use geometry, suppose this A, this is O, and this is B, and this suppose angle N, this is N, and this. If you check this geometry, angle AON is equal to angle MOC, since they are vertically opposite, correct? Now, I need to find out the value of this angle BOM, correct? So look, this is the deviation, this is the deviation, correct? This is the deviation, correct? That means this is the deviation, means better, let me draw it like this. This is the deviation, means this is the actual path. Black line shows the actual path, and following the red line, this is the new path, correct? So this is what we call deviation, and let me denote this by D. Okay, angle of deviation. So how to calculate that? Look, if I use geometry in this case, angle MOC can be written like angle MOB plus angle BOC. Now, angle AO in what? AON is theta1. Okay. What is angle MOB? If you watch it, this will be theta2. And what is angle BOC? This is D. So theta1 equal to theta2 plus D. So angle of deviation is theta1 minus theta2. This is the technique of calculation. Calculating it. Correct? Okay. I will show some numericals also with this. Okay. So this is the one of the thing. This is the one of the way. Correct. But look, in this case, deviation takes place in how, in what way? It took place like this. In what direction? It is in clockwise direction. Correct. Now, let's take another example. Now, the question is, if I take another example of this. Suppose this is the surface of separation of two media, and this is the normal, this is the incident ray, this is the line. Okay. Now, and this is the normal. And after moving to this medium, the light is following this path. Correct. Now you may assume why light ray is moving sometimes towards the normal or away from the normal. I will explain all. Correct? Don't worry about that. But before going to teach you that, let me tell you this and try to understand this concept clearly. Say for example, now look, if I extend this line, this is the original path. Means not original path, it was the initial path, correct? Now what is happening here? Watch it. After refraction, after moving from one medium to another, this was supposed to be theta, this is supposed to be theta 1, and this is supposed to be theta 2. Now, how this deviation takes place right now? Now it is in which direction? It is in anti-clockwise direction, correct? So now how to calculate the angle of deviation now? Simple technique is this. Write it like this: A, this is B, this O, suppose it is B, suppose it is C, this is M, and this is suppose N. Okay. Now, again, what we can write, watch it carefully. Angle AON is equal to angle. Which angle it is equal to? Angle AON is equal to this angle. Look, this theta 1. Why? Because those two angles are vertically opposite. So this is CON. Okay. Now watch it. We need to find out this angle. Okay. This angle means angle BOC. So can I write angle BOC is equal to angle BOM minus angle COM. Correct? Now, angle BOC is what? That is theta 2. And angle BOM is what? Angle BOM, what is that? Angle BOM is, sorry, I made a mistake. It's not theta 2. Look, angle BOC is deviation, correct? Denoted by D. So this is D. What is angle BOM? BOM is theta 2 minus. What is COM? Look, angle COM is equal to angle AON, which is equal to theta 1. So now it is theta 2 minus theta 1. Is that clear? So this is the technique of calculating deviation, angle of deviation. Is it clear? So let me show you a numerical related to this, correct? Okay, watch it. Suppose this is the surface of separation of two media. A ray of light falling like this. Let me draw on normal first. This is a usual technique. Normal first. And then suppose this has become, this rays goes like this. So, and it is given, for example, this is supposed to be 45 degree and this is supposed to be 60 degree. So you need to calculate the angle of deviation. Okay. So what to do then? As I had shown earlier, okay, let me draw a line which is actually following the initial line, Suppose this one. Now, here which angle is the angle of deviation? This is the initial path and this is the new path. So angle of deviation is this. Let me denote this by T. Clear? Now, if I use simple geometry, this angle is 45 degree. So this angle is also 45 degree because these two angles are vertically opposite. And this entire angle is 60. And we need to find out this angle only, correct? So this angle only. So what is that? Look at this. Suppose this is A, this is O, this is B, this is C, this is M, and suppose this is N. So as I said earlier, you can write it like this: AOM is equal to angle CON, and both are equal to what? 45 degree. But we have to find out what BOC. Angle BOC is what? Is the angle of deviation. Clear? That is deviation D. And that is equal to what? BOC is equal to angle, watch it carefully, BON minus angle CON. And what is BON? It is nothing but 60 degree. And what is CON? It is nothing but 45 degree. So remaining is 15 degree. This is deviation. This is the technique of calculating deviation. Is this clear to you? Okay. So now we understood how to find out the angle of deviation, but it is coming in your mind why the rays are bending like this. Okay, sometimes when it moves from one medium to another, why it is moving away from normal, why it is moving towards the normal. Okay, let me clarify it first. Correct? Before going to show you that particular thing, let me tell you something related with this, which is very, very important. And that is what we call relative refractive index. Okay, that is what we call relative refractive index. And before going to discuss relative refractive index, let me tell you something about optical density. You people are quite familiar with this particular word, the rarer medium and denser medium, correct? Now, what we actually mean by rarer medium or denser medium. So let me tell you something with an example, illustration that will looks fantastic. Okay. Watch it. Suppose these are the two different media, correct? This is medium 1 and this is medium. Okay. These are two different medium. And speed of light in this medium is supposed to be V1 and the speed of light in this medium is supposed to be V2. And look, optical density of a medium decided by the speed of light in that medium, correct? For example, so first note of this point, it's very important. The optical density of a medium, optical density of a medium optical density of a medium is decided by the speed of light in that medium. Okay. And remember, optical density has no relation with physical density. Physical density means mass by volume, correct? So this is also a very important point. Optical density has no relation with physical density. Okay. Now, as I said earlier, optical density of medium is decided by the speed of light in that medium. Now, suppose V1 means here V1 denotes the speed of light in medium 1 and V2 denotes the speed of light in medium 2. Okay. And if V1 is greater than V2. What does that V1 greater than V2 means? That means light moves faster in medium 1 than medium 2. If V1 is greater than V2, we can say that the light moves faster in medium 1, then 2. So in that case, we'll say, so we can say medium 1 is optically rarer with respect to medium 2. You cannot say it just by it is optically rarer medium, it is optically denser medium. This is on with the basis of comparison, correct? Or we can say medium 2 is optically denser with respect to medium 1. This is the meaning of optical density, and by which we can say it is rarer medium or denser medium. Means if light moves faster in medium 1 than medium 2, we'll say medium 1 is optically rarer, which is we generally call it rarer medium, and medium 2 is called denser medium. Correct? So this is the idea of optical density, and what is the meaning of rarer medium and denser medium. Correct? It is completely decided by the speed of light in that medium. Correct? Now, a very, very important thing, which is what you call relative refractive index. Correct? What do you mean by relative refractive index? So listen it very carefully. Relative refractive index, which we write like this, R dot I. Correct? Now, think about an example. Say, for example, light is moving from medium 1 to medium 2. Correct? Take this example. Okay. For example, this is the normal, and this is the ray which is falling on the interface. Correct? And let us write this, and suppose this. Okay. Now, this suppose I, this suppose R. Angle of incidence, angle of refraction, I will tell you just now. I will tell you later on. So let me tell you something. So relative refractive index means what? Suppose light is moving from medium 1 to medium 2. So definition of relative, and the speed of light in the medium 1 is v1 and v2. So we write it like this. Relative refractive index of medium 2 with respect to medium 1 is equal to, look at this denotation, mu 1 2, or sometime like this. Okay. Relative refractive index of medium 2 with respect to 1 is decided like this. And what is this definition? Definition is, it is the speed of light, ratio of the speed of light in medium 1 to medium 2. So it is actually v1 by v2. So relative refractive index, let me denote it by R dot I. That will save time. Relative refractive index of medium 2 with respect to 1 is the ratio of speed of light in medium 1 to medium 2. In medium 1 to medium 2. Correct? So it is relative refractive index of medium 2 with respect to medium 1 is the ratio of the speed of light in medium 1 to medium 2. So this is the formula of relative refractive index. Is it clear? Now, for an example, let me show you a problem first with respect to relative refractive index. Correct? So remember one important thing, since it is the ratio of two similar quantities, both are the ratio of speed, it has no unit, correct? So note this point, since refractive index is the ratio of two same physical quantity, it has no unit. Okay? Now, let me show you how to find out relative refractive index. Correct? So, giving an example. Okay. For example, think about this. Okay. Let me take a question first. Okay. Suppose this is surface of separation of two media. This is the incident ray. This is the normal drawn. Okay. And this is the refracted ray. Correct. Now, this is, say for example, any angle. I don't know what angle it is. And this is another angle. Let it be I, let it be R. I don't know what angle this is. But it is given. This is medium 1. And the speed of light in this medium is 3.0 into 10 to the power of 8 meter per second. And the speed of light in this medium is 2.0 into 10 to the power of 8 meter per second. Okay. Clear? Okay. Now, you have to find out relative refractive index of medium 2 with respect to medium 1. Means question is this. What is the value of this? What is the value of 1 mu 2? So as I said earlier, this is actually defined like this. Ratio of the speed of light in medium 1 to medium 2. So what is the speed of light in medium 1? That is 3.0 into 10 to the power of 8 by 2.0 into 10 to the power of 8. So it is 3.3 by 2 is simply 1.5. This is the answer. Is this clear? This is the technique of finding relative refractive index. Now comes to the main portion. Correct? What is that? Because these are the concepts which you require very much before going to proceed the laws of refraction. Correct? So, what are the laws of refraction? Laws of refraction. Now, the question is this, say for example, suppose this is surface of separation of two media. Okay. Now, our light is falling like this, and this is the normal drawn, and this is the path of the ray when it moves to the other media. Correct? So, students, one thing keep in mind, never forget to put arrowhead on the ray diagram. Correct? Because ray diagram without arrowhead carrying marks. Correct? So you people are prepared for board. So this is a very good information for you. So let me tell you something first. This is, say for example, M. This is called M prime. This is N. This is N prime. and this is O, and this is A, and this is B. Look at this. First of all, the ray AO is called incident ray. The ray OB is called refracted ray. Okay, and this is ray AO is called incident ray. Ray OB is called refracted ray. O is called point of incidence. Okay, and NO is called normal. Okay, NO or NN prime, whatever you can say, NO or you can say NN prime, this entire thing is normal, drawn at the point of incidence, correct? So better I write it like this. NN prime is the normal. Okay. Now, this is, say for example, I, this say for example, R. I in this case called angle of incidence. R is called angle of refraction. Okay, I is called angle of incidence, R is called angle of refraction, and MM prime is called the surface of separation of two media. Correct? The medium 1 is medium. So according to the first law, the incident ray that means AO. Okay, the refracted ray, what is that? OB. And the normal, what is that? N prime, drawn at the point of incidence all lie in the same plane. Now, what do you mean by same plane? Same plane means, look, entire diagram I am drawing on the board, correct? So this is a plane. So all this means this incident ray, this normal, at this point of incidence, this refracted ray, all should be lying on this same plane, correct? This is what we call the first law of refraction. Now, the part which is very important with this is the second law, which is also called Snell's law. So give me time, get the time please, so I can erase this. Wait a moment. So second law plays the most important role in understanding the concept of bending or deviation from its original path. The second law of refraction is called Snell's law. So second law is also called Snell's law. Okay. So what the law says, it says that, look, at the time of writing this law, be careful about the thing I'm mentioning here, correct? For a given color of light, for a given pair of media, that means second law depend upon these two factors. For a given color of light, for a given pair of media, the ratio of the sine of angle of incidence to the angle of refraction is a constant quantity called the refractive index of medium 2 with respect to medium 1. Now understood why I taught that thing before? It is because of this. So according to this law, if I want to write the mathematical formulation of this law, the law write like this: sine I, sine means trigonometric sine, by sine of R is equal to this. This is the law. And the entire concept of deviation related with refraction, you can understand in a absolutely fantastic way if you apply this law. Means maja hi aayega. Correct? So let me give a clear understanding of why, when light moves from rarer to denser, why it bends towards normal, why from denser to rarer away, why it falls normally, why don't it deviates, correct? So let me explain it. Okay. So let us try to understand the concept first. Okay. For an example, assuming here the light is moving from medium 1 to medium 2. And this is the as usual a surface of separation. As usual a surface of separation. And let me draw first the normal. Now I will not draw, really I will not draw the refracting ray. I will draw only the incident ray. Okay, then I will draw, after giving you the concept, I will draw the refracting part, correct? So assume this is the incident ray. Okay, so say for example, this angle is I and this is the angle of incidence. This is medium 1 and this is medium 2. And speed of light in this medium is v1 and the speed of light in this medium is v2. And assuming here v1 is greater than v2, that means light is moving from which medium to which medium? Moving from rarer to denser medium. Okay. Now just try to understand the concept. I'm writing now. I'm going to write the Snell's law. Sine I by sine of R is equal to, as usual I said, is equal to this. And I gave the definition of relative refractive index mu12 is equal to, if you remember it, V1 by V2. So writing down like this, sine I by sine R is equal to V1 by V2. Correct? Now, here I have considered V1 is greater than V2. That means numerator is larger than denominator. And we know in a fractional number, if the numerator is more than denominator, the ratio of that is always greater than 1. So very usual example. Suppose this 20, this is 5. What is it? 4. So it is obviously greater than 1. Correct? So what we can write, sine I is greater than, sine I by sine R is greater than 1. So we can write sine of I is greater than sine of I. And if you have an idea of trigonometry, we know the sine 0 degree is 0, sine 30 degree is half, sine 45 degree 1 by root 2. Correct? So sine 60 is root 3 by 2, sine 90 is 1. That means as the value of angle increases, the value of sine theta also increases. That means if sine I is greater than sine R, it implies that I is greater than R. That means what? The angle of incidence would be more than the angle of refraction. Correct? Now, let me draw the original path by the black line. Correct? Okay, this is the original path. Now let me draw the refracted ray. Now the question is what? This angle I should be more than R. That means the ray which is going to be refracted in the medium 2 must make an angle lesser than this black line. Correct? With the normal. That means it will bend like this. Correct? Is it clear? So it is quite clear from the diagram. If this angle is now lesser than this angle. Correct? So that is why when light moves from rare to denser medium, why it deviates towards the normal. Is it clear? This is one of the very good idea. Point number 2. If light moves, say for example, medium, say for example now, change the medium, correct? Interchange the medium, correct? So let me take another example. Now I'm going to take a different case. Let this will be the surface of separation. And again, as usually what I'm doing, first I'm drawing the incident ray. And look at this. This is normal. Okay, this is the normal. And this is the incident ray. And let it be I again. And now make it medium 2 this or make it medium. Okay. Now suppose medium 1 and this is medium 2. And the speed of light in this medium is supposed to be V1, speed of light is medium V2. Now light is moving from which medium to which medium? Now it is assuming here V1 is lesser than V2. That means light is moving from denser to rarer medium. Okay. Now watch this carefully. What will happen? Okay. Again applying Snell'sLaw. Sine of I by sine of R is equal to this. This is Snell'sLaw. And we know this is equal to V1 by V2. Now, which is larger now? V2 is more than V1. If denominator is more than numerator, so this ratio must be lesser than 1. Take this example now. If say for example numerator is 1 and denominator is 5, so it is obviously less than 1. So if it is sine I by sine of R is less than 1, therefore sine of I less than sine of R, hence I is less than R. Is it clear? I is less than R means what? I is less than R means what? Look at this very carefully. Now let me draw the diagram. Okay, let's draw the diagram again. Draw the original path by the black line. Okay, draw the original diagram by the black line. Now tell me, you have to tell me better. If it is I, this is also I, but what it requires, R is more than I. This much is I, correct though? But the requirement is R must be more than I. So what should I do? I will draw the refracted ray more away from the normal, correct? So what does that mean? It means simply this angle is larger than this angle. So this is why, while moving from denser to rarer, light moves away from normal. Is it clear? Okay. Now, if the light falls normal, what will happen? Clear? If light falls normal, so let me do it like this. Say for example, now light is falling normally on the surface of separation. Okay, what will happen? Now, what is angle of incidence? Angle of incidence means this is normal, this is the incident ray, this is the angle. Now, since the light is following the normal, that means this angle is 0 degree now. So when light falls normally on the surface of separation, angle of incidence is 0 degree. Correct? So look, again applying Snell's law. Sin I by sin R is equal to mu 1 2. Now, what is this? This is medium 1, speed of light is v1, this is v2, correct, medium 2. Maybe this is rarer, this denser, whatever it may be, correct? Only difference v1 is not equal to v2, correct? v1 is not equal to v2. What does that mean? The mediums are different. Now, we can write this as mu 1 2 sin of R is equal to sin of I. What is the value of I? As I said in this case, in case normal incidence, I equal to 0. So if I put I equal to 0, sin 0 degree is 0. That means this sin of R is equal to 0 and this cannot be equal to 0. So what does that mean? Sin R equal to 0, hence R equal to 0. That means what will happen? The light ray will move straight along, following the original path. In this case, you will find no deviation. That is why at the time of writing the definition of refraction, we should mention the light falls normally on the surface of separation. Sorry, light falls obliquely on the surface of separation, not normally. So student, up to this today, follow my next video for the topic starting from relative refractive index, apparent depth, real depth, etc. Thank you.